Hello children, welcome to my channel. This is area and perimeter of plane figures or two-dimensional mensuration, 2D mensuration of class 9, part 3. Okay. In part 1, I have already explained how to find area and perimeter of different types of triangles. Okay. In part 2, I explained I solved and explained some examples related to triangles. This part is completely for quadrilaterals, different types of quadrilaterals. Okay, area and perimeter. So first, let us start with the quadrilateral. A specific quadrilateral. Okay, suppose A, B, C, D. Suppose in this quadrilateral, one diagonal is given, okay, and the distance of this diagonal from the remaining two vertices are given. Means perpendiculars are drawn. Perpendicular. Suppose this is M, this is N. Okay, one diagonal is given and the perpendiculars from the remaining two vertices on the diagonal are given. In this case, how to find the area? Area is equal to, you can see this quadrilateral has two different triangles. One is ABC, the other is ABC. So area of this quadrilateral will be area of triangle ABC plus area of triangle ADC. Okay. Okay. Now from the figure, see what is the area of triangle ABC? Half into base into height. Base is AC, height is BM. Then area of triangle ABC is also half base into height, half into AC into BN. We can take half and AC common, remaining is BN plus DN. So this is the formula: half into one diagonal into sum of the perpendiculars on the diagonal from the remaining two vertices. This is the formula: half into one diagonal into sum of the perpendiculars on the diagonal from the remaining two vertices. This is for such type of quadrilateral. Now, second type. Second type, this is part number 1 over number 2. Suppose in a quadrilateral, diagonals are perpendicular to each other. Okay. This is a quadrilateral in which diagonals are perpendicular to each other. This is 90 degrees. Okay. The diagonals bisect each other or not, that we don't know, but simply they are perpendicular to each other. In this case, area will be half into product of diagonals, AC into B, or if you generalize, half into D1 into D2, half into product of the diagonals, if the diagonals are perpendicular to each other. Okay, so this formula can be used for such type of quadrilaterals in which diagonals are perpendicular to each other. So definitely this formula can be used for a kite also, because in a kite the diagonals are perpendicular to each other. For a rhombus also, because in a rhombus diagonals are perpendicular to each other. For a square also, okay, for a square also. When I will move to rhombus and square, again I will go back to this formula, you will see. So this is second type. Now let us move to third type, that is rectangle. Okay, now we move to rectangle. Rectangle. Suppose this is A, B, C, D. It is a rectangle. Each angle is 90 degree. Okay. Now from lower classes you already know the formula for area. Area is equal to length into breadth. Okay, length into breadth. Perimeter is equal to 2 whole L plus B, 2 whole length plus breadth. Okay, then suppose this is L, this is also L, this is B, this is B. If we join AC, we will have the diagonal. Suppose this is D. If we join BD also, we will get the same diagonal. Okay, the length will be same. So I am not joining BD, simply I have joined AC. So AC is the diagonal. Now let us develop the relation among L, B and D. L, B and D. Now see, triangle ABC, it is a right triangle. So we can use Pythagoras theorem. And D is the hypotenuse. L and B are the sides containing the right angle or the legs of the triangle. So using Pythagoras theorem, we can have d square is equal to L square plus d square. So these are the three formulas of a rectangle that you have to remember. These two you already knew from lower class. This is a new formula you have to remember. Okay. Next we have, after rectangle we have square. Okay, you already know what a square is. It is a special type of rectangle in which adjacent sides are equal. I have already explained about this in the chapter rectilinear figures. Square, rhombus, parallelogram, trapezium, rectangle, etc. Okay, I have already explained. All the properties I have explained. A square, in a square, all the sides are equal and each angle is 90 degree. Okay, it is very special. Area is equal to, suppose each side is A, then area is equal to A square. Okay, area is equal to A square. Then perimeter is equal to, sorry. This formula you knew from the lower class. Okay, area is equal to side square or A square. Okay, but in number 2, if in a quadrilateral diagonals are perpendicular to each other, then we can use the formula to find the area, half d1 into d2. The same formula can be used in square also, because in a square diagonals are perpendicular to each other. So if we join AC and BD, we will get the diagonals. This is one diagonal and this is another diagonal. Let the point be O, means point of intersection be O, they are perpendicular to each other. So again we can say that is equal to half into d1 into d2, half into product of the diagonals. But in a square, diagonals are equal. Okay, half into d1 into d2 in a square, d1 d2 are same, diagonals are equal. So half d into d. Now what is d into d? D square. Okay, so d into d is d square. So remember this formula, area of a square is equal to A square or half d square, same thing. Okay, you can use side to find the area of a square, you can use diagonal to find the area of a square. When side is given, use this one. When side is not given, use this one. Okay, so this is formula for area. Then perimeter. Perimeter is equal to A plus A plus A plus A, that is 4A. for A. Okay. Now let us find the relation between means among the diagonals and the side. Okay. Suppose let us take this triangle AOB. AOB. Okay. From here you can get the relation. See, from here you can get the relation. Okay, the relation between diagonal and side we can get from here. Okay, we don't need to take this triangle, directly we can get from here. B square is equal to A square, or B square is equal to 2A square, D is equal to 2A square root over, or D is equal to root 2A. So this is formula for area. A square or half D square. This is formula for perimeter, and this is the relation between diagonal and a side of a square. D into root 2A. If you forget this, no problem. Okay, I also forget this one, but I get this from here, from this formula, area formula. Okay, so this is for square. Now let us move to rhombus. Now let us move to rhombus. Now let us move to parallelogram. Okay, parallelogram. This is number 5. Parallelogram. A, B, C, D, parallel, 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 parallel. Okay. Let us go for perimeter first. Perimeter is equal to sum of all the sides. Okay. Sum of all the sides. AB plus BC plus CD plus AB. Okay. But AB and CD are equal. BC and AD are equal. So instead of AB plus CD, I can write 2AB because they are equal. Then instead of BC plus AD, I can write 2BC. Okay, 2BC, 2 common AB plus BC. Okay, 2 common AB plus BC. So we can generalize this. Sum of any two adjacent sides. Okay, so perimeter is equal to 2 whole into sum of any two adjacent sides. This is for perimeter. Now let us go for area. Area is equal to, let us join BD. Okay, let us join BD. After we join BD, we get the diagonal BD, and that diagonal bisects the parallelogram, means divide the triangle into two triangles which are congruent to each other. Okay, this I have told in rectilinear figures. It was one property of a parallelogram. Each diagonal of a parallelogram bisects the parallelogram, means it divides the parallelogram into two triangles which are congruent to one another, each other. So these two are equal in all respects. So area will also be same. If area of this is x, area of this will also be x. Okay. What will be area of the parallelogram? 2x. Okay, or 2 into area of triangle ABD. Okay, 2 into area of triangle ABD. Now, how to find area of triangle ABD? Do not look at this one. Forget this one. Forget BCD. Simply look at ABD. How to find area of triangle ABD? From D, we have to draw a perpendicular on AB. Let it be T. Okay. Now, area of triangle ABD is equal to half base into height. 2 into half into base into height. What is base? AB. What is height? DP. DP. So 2 cancel AB into DP. Okay. AB is one side of the parallelogram, and what is DP? Distance between the two parallel sides. Distance between the two parallel sides, that is AB and DC. Okay, also known as height of the triangle. So we can generalize this. We can write here base into corresponding height. Here height means distance between the parallel sides. In case of triangle, height was distance of a side from the opposite vertex, perpendicular distance. Here also perpendicular. Okay. So this is about parallelogram. Now let us move to rhombus. Number 6. Rhombus. Okay. A rhombus is a special type of parallelogram in which all the sides are equal or adjacent sides are equal. A, B, C, D, all the sides are equal. This is a rhombus. Okay. If each side is A, suppose, perimeter will be A plus A plus A plus A, that is 4A. So you can see the formula for perimeter of a rhombus and the formula for perimeter of a square are same. Square also for a, rhombus also for a, but there will be difference between their area. Okay, there will be difference between their area. In case of parallelogram and rectangle also, perimeter formula is same. In case of rectangle, perimeter is equal to 2 whole sum of the adjacent sides. In parallelogram also, perimeter is equal to 2 whole or 2 into sum of the sum of the adjacent sides. So perimeter over. Now let us go for area. Area is equal to, see, if we join AC and BD, means we get the diagonals. Let us join AC and BD. AC and BD. We know that in rhombus diagonals are perpendicular to each other. They are not equal. In a square, diagonals are perpendicular and equal also. But in a rhombus, diagonals are simply perpendicular. They are not equal. Okay. So let us say one diagonal is D1, the other diagonal is D2. So here area is equal to, I have given in number 2. If diagonals of a quadrilateral are perpendicular to each other, then the area is equal to half D1 into D2. Okay. The same formula can be used here also. 1 by 2 D1 into D2. Okay, because diagonals are perpendicular. Whenever diagonals are perpendicular, use this one. So area is half D1 into D2. Now there can be another formula for area, because a rhombus is a special type of parallelogram whose area formula is base into height. So the same formula can be used here also. Okay, we can take any one side as the base and corresponding height. So base into height. Base into height. Here base can be any side, suppose A, every side is A. I am taking A into height means distance between the parallel sides. Suppose from D I will draw a perpendicular on AB. Okay, let this point be P. Let DP is equal to H. Okay, distance between the parallel sides be H. Height is H. A into H. Okay, so area is equal to A into H. Also half divided into 2. Both formulas are applicable. When you have diagonals, use this formula. When you do not have diagonals, but you have side and corresponding altitude or height, means the distance between the parallel sides, then use this formula A into H. So this is for rhombus. Then the last one is trapezium. Okay, you know what is a trapezium? It is a quadrilateral in which one pair of opposite sides are parallel to each other, but the other two, means the other pair is not parallel. AB parallel to DC, but this AD is not parallel to DC. Okay, so this is the trapezium. Now its perimeter means sum of all the sides, that is not a big deal. Okay, you can find. If you have all the sides, then you can find. Let us go for area. Area is equal to, the derivation is not necessary. Okay, so directly I am giving the formula. Area is equal to half into sum of parallel sides into distance between them, or we say height. Okay, suppose this is A, length of AB is A, length of BC is B, distance between them is, suppose, H. Distance between them is H, means DP is H. So here formula means the area will be half into A plus B into H. Half into A plus B into H. Okay, so these are the different formulas to find area, especially area. Perimeter is not a big deal, you can find by adding on the sides. So these are the different formulas to find the area of different types of quadrilateral. Okay, trapezium, rhombus, parallelogram, rectangle, square. Okay, then kite, or any quadrilateral in which diagonals are perpendicular to each other, or any quadrilateral in which one diagonal is given and the distance of the diagonal or perpendiculars on the diagonal from the remaining two vertices are given. Okay, so this is it. This is the end of part 3. Thank you for watching.